explore the expected failure times plot. So we're launching WebWorld++, and we scroll down to Test and Planning, right-click, we click on Test Design, and then we select the second option, Expected Failure Time Plot, and we click OK. Once we've done that, it opens a chart, a plot that looks just like that. So this is the default configuration of the expected failure time plot. What do we got here? We have a number of units on the y-axis and the number of hours on the x-axis. And in this case, we have 5 units, 5 units that behave according to this failure distribution, a 2-parameter variable with beta of 2, so shape parameter 2 and scale parameter of 500. Clearly that can be changed to any value. But simply tell us if we are to conduct a test, how long will it take before I see some failures? Or if I run the test for a certain number of hours, how many failures am I expecting? And this is to avoid running a test for, say, 3 months, 6 months, not getting any failure, not getting anything, and throwing a lot of money away. So we're going to make some changes to our configuration. So say, for example, we're dealing with 10 units. And we're also going to change the failure distribution from 2 to 500. We're going 2 to 12,000, like in a previous example. And we click OK. So if we were to have, like in the previous example, 3 months available, 2,160 hours available, how many failures do we expect? And the answer is you're lucky if you get 1, because here we got 2,200 and we haven't even got the second one. Okay, this is 90% two-side confidence, so there's still a 5% below and a 5% above, but statistically we can say we're lucky if we get 1. And like we did in the previous example, what we did, there may be a situation where we can deal with usage acceleration, so we are dealing with the increased number of cycle, and that enables us to accelerate. So in the previous example, we accelerated with a factor of 5. What has changed? Nothing has changed in terms of shape. What has changed is the x-axis. So now our 2,160s gives us a little bit more flexibility. So probably we're going here, 2,000. So we're probably likely to get at least 3 failures, possibly even more. So 2,160 is about here. Yeah. So we could have 4, even 5. It depends, but definitely we get 3 failures. So we collect some failures. Say, for example, we can input the failures inside here. So we paste them and we get the results. And clearly these failures are not what we were expecting in terms of fitting. They are pretty much on the border, on the edge, which implies that our acceleration from our actual test is higher than what we've anticipated. So in this case, it's not 5, but it could be, say, probably 8 or 9. Let's have a look. 8, yes, it could be 8 or even 9. So the expected failure time plot is very useful utilities to anticipate how many hours we should test before getting some meaningful failure. Thank you for watching.